Morning. This presentation walks through a full penetration test against CYb-B610 Level 1 virtual machine. The objective is to demonstrate how vulnerabilities are identified, validated, and exploited to gain root-level access. The process follows a realistic attack chain, beginning with reconnaissance and ending with persistence and system compromise. The purpose of this lab is to simulate a controlled attack scenario. The goal is not just to gain access, but to understand how weaknesses in outdated systems can be chained together. Each step builds on the previous one, showing how attackers move from discovery to full system control. This lab consists of two virtual machines configured on a host-only network. The Kali system acts as the attacker, while the CYb-B610 serves as a vulnerable target. Using a host-only network ensures the isolation from external systems while still allowing direct communication. Establishing connectivity is critical because all reconnaissance and exploitation steps depend on accurate network visibility. And below you'll see my Kali IP and my CYb-B610 IP. This scan identifies both open ports and service versions. Version detection is important because it allows us to map services to known vulnerabilities. In this case, the Apache and OpenSSL versions are significantly outdated, which immediately suggests the presence of exploitable weaknesses. NICTO performs a focus scan on the web application layer. It confirms that the web server is not only outdated, but it also is misconfigured. Missing security headers and exposed vulnerabilities increase the likelihood of successful exploitation, especially when combined with legacy software. Here you'll see my SMB service analysis. We identified Samba 221 alpha, and then legacy service exposure and additional attack surfaces. An SMB enumeration provides the insight into file sharing services running on the system. The Samba version identified obviously is outdated and potentially exploitable. Even though it is not used as a primary attack path in this scenario, it reinforces the system's overall weak security posture. Now we're going to dive into our vulnerability research. So search exploit is used to correlate identified services with known exploits. So mod_SSL vulnerability stands out because it enables remote code execution through a buffer overflow. This is a critical finding as it allows direct system access without authentication. Before executing the exploit, it must be compiled into a usable binary. Linking the appropriate SSL and cryptographic libraries ensures compatibility with the target environment. This step prepares the exploit for execution against the vulnerable service. Once compiled, the exploit is executed against the HTTPS service using a specific memory offset. This triggers a buffer overflow in the OpenSSL component, allowing arbitrary code execution. As a result, a shell is spawned on the target system. As you can see below, I created a shell, and from the screenshot, I was attempting to create my own user account. So I added a username and a password. At this stage, access is confirmed, but privileges are limited. The Apache user does not have administrative control, so additional steps are required to escalate privileges and gain full access to the system. A local exploit is transferred from the attacker machine to the target using a temporary HTTP server. This method is simple and effective for moving files into a compromised environment. Next is the exploit targets a vulnerability in the Linux kernel's ptrace functionality. By attaching to a running process, it injects malicious code and escalates privileges. This step demonstrates how attackers move from limited access to full system control. And as you can see below, I was able to log in as root in the Kyoptrix virtual machine. The system now confirms root level access. At this point, the attacker has unrestricted control over the system, including the ability to modify system files and maintain long-term access. Persistence ensures that access remains even after the initial exploit. Creating a new user account allows the attacker to log back into the system without repeating the exploitation process. As you can see below from my screenshots, I created my own user account and password, so I'm able to log in and log in with root access. The newly created account is used to log in to the system. Root access is then obtained through a legitimate authentication, demonstrating that persistence was successfully established. And here below is my attack lifecycle. The sequence illustrates how multiple vulnerabilities can be chained together. Each phase builds upon the previous one, ultimately leading to full system compromise. And here are some defense recommendations. Even without upgrading systems, risk can be significantly reduced through proper configuration. Restricting privileges and monitoring activity would make exploitation much more difficult. Here are my conclusion and some key takeaways. And this lab demonstrated how vulnerable legacy systems can be systematically compromised using publicly available tools and techniques. The attack was not dependent on a single flaw, but rather a combination of outdated services, weak configurations, and missing security controls. During the exploitation phase, an issue was encountered with the exploit code initially provided through CYb-B610. The code was outdated and incompatible with the environment, requiring troubleshooting and the use of alternative exploit methods. This highlights an important real-world consideration. Public exploits are not always reliable or immediately functional, and attackers as well as defenders must be able to adapt when tools fail. Once initial access was achieved, privilege escalation was performed by leveraging a known kernel vulnerability. This step demonstrated how limited access can quickly escalate into full system control when proper protections are not in place. From a defensive standpoint, this exercise reinforces the importance of maintaining updated systems, restricting unnecessary services, and implementing layered security controls. Even without replacing legacy systems, organizations can reduce risk through hardening techniques, monitoring, and enforcing least privilege. Overall, this lab reflects how attackers think, adapt, and chain vulnerabilities work together, emphasizing the need for proactive and continuous security measures. And the final slide, here are some references to look into for more information. If you like this video, hit the like, subscribe. Thanks. Have a good one.